Assalamu alaikum, my dear students. I hope all you are well at your home. I am Shafiul Alam Shetu. I am the senior teacher of mathematics, Milestone School and College. We all know we are passing very much tough day for this disease. In the meantime, Milestone School and College initiate a very great process for this online class. This would be very much helpful for you to continue your study at your home. You can look after the online CW and submit your SW in the comment. This is a very much continued process for your study. So let's start today's class. My dear students of class 8, welcome to video class on mathematics. I am Shafiul Alam Shetu. I am the senior teacher of mathematics. Today I am going to discuss chapter 9, Pythagoras Theorem. That is very important chapter for you, and every year in JSC there is a creative question from this chapter. So this chapter is very important, and you have to understand this chapter more clearly, and I will try my best to make you understanding. Let's start now. At the end of this lesson, you will be able to explain right angle triangle, prove Pythagoras theorem with the help of two right angle triangles, proof of Pythagoras theorem, proof of Pythagoras theorem with the help of similar triangles, proof of Pythagoras theorem by the algebraic proof, proof of converse Pythagoras theorem, basic discussion. In the 6th century BC, Greek philosopher Pythagoras discovered a special property of right angle triangle. This property of right angle triangle is known as Pythagoras theorem. Right angle triangle. We know that the sides of a right angle triangle have got special names. Let's see what are the special names. The sides opposite to right angle as hypotenuse. That means this is a right angle triangle, and AB is opposite of right angle, so this is the hypotenuse. That means AB is the hypotenuse. The sides containing the right angle as base and height. It means other two sides. This BC is the base and AC is the height. So in the figure, ABC is a right angle triangle where angle ACB is a right angle equals to 90 degree. That means on right angle equals to 90 degree. AB equals to C is the hypotenuse. BC equals to A is the base. That means this alphabet, small alphabet CA, we just make it let. That means let AB equals to C, let BC equals to A, and AC equals to B is the height. Now, key points of Pythagoras theorem. The sum of squares of two sides is equal to the square of the measurement of the hypotenuse. For better understanding, I am using some examples. From the above figure, the sides A, B and hypotenuse C, then C square equals to A square plus B square. From this language we get the sum of squares of two sides. The sum of squares of two sides, that means A square plus B square, is equals to the square of the measurement of the hypotenuse, and it is equal to the square of the measurement of the hypotenuse, that is C square. Example, suppose in a right angle triangle, two sides are A equals to 3 cm, B equals to 4 cm, then hypotenuse C will be, we have to use this formula for finding C or hypotenuse. That is the formula. And putting the value of A and B, we get C square equals to 9 plus 16, C square equals to 25, and we know C equals to root over 25, that is 5 cm is the hypotenuse. This is the formula, or this is the key points of Pythagoras theorem. Now, Pythagoras theorem. In a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the two other sides. That means this language and this language are the same. This Pythagoras theorem has been proved in various methods. My dear students, our next proof is proof with the help of similar triangles. In here you can see there are two triangles divided by CH. In the figure you can see. So we have to prove with the help of these two similar triangles. Proposition: let in triangle ABC angle C equals to 90 degree and hypotenuse obviously opposite of 90 degree or opposite of angle C, opposite side. Hypotenuse AB equals to C, BC equals to A and AC equals to B. It is required to prove that AB square equals to AC square plus BC square. Therefore, C square equals to A square plus B square. Again I am saying the proposition: let in triangle ABC angle C equals to 90 degree. So obviously the opposite side is the hypotenuse. So hypotenuse AB equals to C, and the other two sides BC equals to A and AC equals to B. It is required to prove that AB square equals to AC square plus BC square. Therefore, C square equals to A square plus B square. Now, construction. Draw a perpendicular CH from C on hypotenuse AB. The hypotenuse AB is divided at H into two parts of D and E. As you can see from the figure, this CH perpendicular divided AB into two parts, D and E. Let's see the proof. Steps. First step is in triangle BCH. In here there are two triangles. In triangle BCH and triangle ABC, this little triangle BCH and the whole triangle ABC, angle BAC equals to angle ACB, as since both are right angle triangle, and angle CBH equals to angle ABC, as you can see from the figure. Therefore angle B is common, because this triangle BCH and this triangle ABC, angle B is common between these two triangles. And we know if the two angle of any two triangle are equal, then the other angle also equal. So we can say these two triangle BCH and ABC, they are similar triangles. So we can write, so triangle BCH and triangle ABC are similar. Therefore BC divided by AB, BC divided by AB equals to BH divided by BC, BH divided by BC. So we can write, instead of BC A, instead of ABC, instead of BH, E, instead of BC, A. Similarly, triangle ACH and the whole triangle ABC are also similar, the same way. Therefore, AC divided by AB equals to A is divided by AC, and we put down the value. Instead of AC, B, instead of AB, C, instead of A is D, instead of AC, B. So from the ratios 1 and 2, in here we marked this one is first and this one is second. So from the ratios 1 and 2 we get, if we multiply, cross multiplication, if we do cross multiplication, then we get from the first A square equals to C multiplied by E, and from the second B square equals to C multiplied by D. Therefore, if we add these two equations, at first we will add left hand side A square plus B square equals to, we will add right hand side C multiplied by E plus C multiplied by D, and if we take common between these two terms, we will take C common and we get E multiplied by D. And just from the figure you can see C multiplied by C, because since C equals to E plus D, in here you can see from the figure C equals to E plus D, they are divided into two parts. So C multiplied by C, that would be C square. Therefore we can write C square equals to A square plus B square, that is the desired root. So my dear students, our next proof is alternative proof of Pythagoras theorem, algebraic proof. So let's see the proposition. Let in triangle ABC, C is the hypotenuse. In here, if you think any of this triangle, C is the hypotenuse and AB be the other two sides, it is required to prove that C square equals to A square plus B square. Construction. Draw four triangles congruent to triangle ABC as shown in the figure. That means we have to draw another three triangles that would be the congruent of these triangles. That means these four triangles will be the same. Let's see the proof. Steps. From the figure, the larger region is a square. You can see this is the larger region and that is a square shape. You can see from the figure that is the square shape, and each side of the square is A plus B, and each side of this square, you can see each side of this square is A plus B, because this side is A plus B, this side is A plus B, this side is A plus B, and this side is A plus B, and that is the larger region, which is the square. So area of a square is A plus B whole square, because we know since area of a square equals to length of one side whole square. So this is the larger region square. Now the inner smaller quadrilateral is also a square. You can see this inner smaller quadrilateral is also a square. Each side of the square is C. In inner smaller quadrilateral, you can see each side of this square is C. So area of the square, we know the length of one side is square, and length of one side is C in here, that would be the C square. So from the figure, the area of the larger square region equals to sum of the areas of four triangular region plus area of a smaller square. You can see the total area of the larger square region. We can write the sum of the four triangle region plus area of this smaller square. So we get already the area of the larger square region is A plus B whole square, and the triangle area is half multiplied by AB, that is base into height, half multiplied by AB. Every 4 triangles are same, plus area of a small square is C square we get from here. Now we know the formula. A plus B whole square equals to A square plus 2AB plus B square equals to, and if we take common half from here, we get AB plus AB plus AB plus AB plus the rest of the thing is C square, or A square plus 2AB plus B square equals to half this 4AB we can write, if we make the sum, 4AB plus C square. And if we reduce from this 4 by 2, we will get 2AB plus C square. And if we make the change side of this 2AB, if we take this 2AB to the left hand side, the sign will be the change. So A square plus 2AB minus 2AB plus B square equals to C square. So we can reduce 2AB and 2AB from here, because this one is plus and minus. Therefore C square equals to A square plus B square. Now, converse of Pythagoras theorem. This is the opposite sequence of Pythagoras theorem. If the square of a side of any triangle is equal to the sum of the squares of other two sides, the angle between the latter two sides is a right angle. Let's see the proposition. Let in triangle ABC, AB square equals to AC square plus BC square. It is required to prove that angle C is a right angle. Construction. Draw a triangle DEF so that angle AF equals to one right angle and EF equals to BC and DF equals to AC. Let's see the proof. DE square, the other triangle, DEF, DE square equals to EF square plus DF square. So we can write, instead of EF square, BC square, instead of DF square, AC square. So instead of BC square and AC square, we can write AB square. Therefore DE equals to AB, omitting a square from both sides. That means if the square is in the both sides, we can omit them. Now in triangle ABC and triangle DEF, BC equals to EF, AC equals to DF, you can see from the figure, and AB equals to DE, and this is the triple S side side side. So we can write triangle ABC congruence of triangle DEF. Therefore angle C equals to angle F. Because these two triangles are congruent, we can write all the sides are equals to one another and all the angles are equals to one another. Then since angle F equals to one right angle, therefore angle C equals to one right angle, and that is the desired proof. So my dear students, I have discussed the theorem from Pythagoras, and I am tried to prove this theorem. We'll use little bit more step to make you better understanding. I think this will help you very much. So please observe my video very carefully, and more you will understand these theorems very easily. And we will meet again chapter 9. Okay, so I am Shofil Alam Shetu. This is enough for today. Stay home, stay safe. Assalamu alaikum.